You must never and ever be afraid of a challenge. Alright, I can share natural science. Share forces. Define for us what is a force. Provide a definition for a force. Provide a definition for a force. O ka reng ha ba define la force o aus. Come on, define for us a force. Not being specific whether contact or non-contact force, but they are just saying define a force.
A force is a push, is a pull, push external.
A force is a pull.
Push or a pull of an object.
A force is a pull or a push of an object. A force is a pull or a push of an object. Now, depending on the amount of air that I provide on this object, and the first thing I must overcome the friction of which this object is resting on. Because it is in contact with the surface. That simply tells you only the frictional force act down on that object, and then that frictional force it is the force that opposes the movement of that object. So come on, before you can even apply a force, before something can even move, you must overcome this friction, the static friction of that object. The static friction being the friction that an object possesses when it is resting. So let us not even go there as to define first what a force is. Let us go and say it is true to say that a force is a pull or a push of an object. But we know that for that object to be pushed or to be pulled, there has to be a friction that we need to overcome. Therefore, we can say, all right, it is true that a force, it is a pull or a push of an object once the frictional force is what now is overcome. Because frictional force is not only the static friction, but the kinetic friction of an object when the object is resting. We also having friction in terms of air resistance. Because what is that? That is it opposes the movement of an object. You are an object trying to move forward. There is a frictional force, which is air resistance, that is trying to resist the movement of that object, and it is always acting in the opposite direction. So an object that is resting, we are therefore saying now you need to overcome the static friction of an object. You need to overcome the static friction of that object before it can even begin to move. And you must ensure that the amount of force that you are applying on an object is greater than what now? The weight of that object. Because can you overcome the weight of this object? It will never move if I try to apply a force. This object is moving. Why? Because first of all, you overcome the static friction between what now? The object, ailing this vapor up, leading the table. There's a friction that is holding this object from moving. Because answer grade 11 Newton's law, why this object will keep on moving, why this object will remain at rest. There are some external forces that needs to be overcome. But for grade 9, when this vapor up is resting on the table, The first thing before it can even begin to slide, you must overcome the static friction. The static friction is what now? It is the friction that is holding this object stationary. So how is because I overcame first the static friction of the object, and then in the amount of the force that I'm applying on the object is greater than the weight of that object. So that is when this object begins to move. You overcome the weight first of all, secondly the static friction which is holding the object at rest. These are important facts. So you need to overcome the static friction of an object and the weight of the object before that object can even start to move. Those are the two things primarily that we need to overcome: the static friction that is holding the object at rest, and then what now? The weight of that object. Even we move again, because the amount of a force we apply is greater than what? The weight of that object. And because it is greater than the weight of the object, you will be unable to overcome the static friction of that object. On a 50 liter ya metsi be re re e phamise mohlomong kapa e jare o tloe mona o ye hile le go e phamisa, maybe wa o e phamisa fela to fumantsela go boima, because ha o e phamisa jare o tlo tlameha o overcome eng pele, o tlo tlameha o overcome the weight of that object, which is what now? Mass multiplied by the gravitational acceleration. And then later, if we pull out dim, we will need to know the amount of potential energy that is required. But we will deal with that when time is right. So we are just saying, no way, provide a definition for a force. And then you have applied for us the definition, the way we root to encate. A force is a pull or a push of an object. Naked way extend so that you understand the thorough namu and because there are conservative and non-conservative forces, and then those forces how apply an object on an object, how apply a force in an object to force applied in but when I move an object force we applying, the air resistance is the one doing work as the object is moving. But we will deal with that. So we are saying, okay, it's fine for now that a force is a pull or a push of an object. The force being in direct contact with the object that needs to be moved. Now, this is something very important. If you have an object that is resting on the surface, the first thing, this object, maybe it is a box, it has to have weight. Another weight. And how do you find the weight of the object? The mass of that object. You multiply that by the gravitational acceleration, because the gravitational acceleration is the force that points everything towards the center of gravity. Oh my father, gravity. Now, if you move out this object, I am displacing that object from the initial position, initially at the initial position, to a final position. The weight of the object I change because it is the same box being moved from state A to state B. Now, when we are moving that object from one state to another, we are saying there is a displacement. The object is being displaced. There's a changing position of that object. And then we refer to that position as the change, the delta. The delta key into the change to say we choose it from the initial position to the final position. In the at rest, maybe the distance is 0. We choose from 0 to final, maybe distance is only 2 meters. From 0 meter in a linear to final displacement is a 2 meter. We move it 2 meter distance, and then as it is moving, remember it is resting on a table. So as it moves from the initial state to a final position, it undergoes it encounters frictional force. There's a friction. So the first thing, how move this object you must overcome the frictional force holding in the object in contact with the table. And then secondly, you have to overcome the weight of that object. So that in terms of how the are practically they make more sense. Because what one of our test whether do you understand into it, push. Then how to reason? Are you able to scientifically reason? Or now what is happening here? So remember, there are two things. When an object is resting on the surface, we need to overcome the static friction, which is what now the friction that is holding as an object stationary. Secondly, there's what we call kinetic friction. Kinetic friction is how object is object you need to overcome static. Static means it is resting. You need to overcome the static friction of the object. You need to overcome the kinetic friction. The kinetic friction is the friction that is acting when an object is in motion. So when the object is in motion, it no longer encounters a static friction, but it's undergo kinetic friction. Kinetic friction is the friction that is acting when an object is moving. Static friction is the friction that is acting when an object is resting. Those are the two fundamental things. Hey, so come on, Mona, we have two things. Static friction. Static friction, it is the frictional force that is acting when an object is at rest. We are therefore saying this is the friction that acts when an object is resting. Again, an actor between two surfaces, the surface of the object and the surface where the object is resting. Right. And then we have kinetic friction. Now we are saying this is the frictional force. This is the frictional force acting when the object is in motion. So when an object is in motion, it no longer undergoes, it no longer experiences static friction, but kinetic friction. And static friction is always greater than kinetic friction. The first we talk the amount of energy that you supply when it is already in motion. So come on, overcome it. You need more energy than how say it's That's what we call static and kinetic. So static is always greater than the friction the kinetic frictional force. So we are therefore saying the mu s is always greater than the mu k. K into the coefficient of static friction is always greater than the coefficient of kinetic friction. But for when I don't want these things, I want to root grade 9, but in root so that you are more broader in terms of understanding. Brothers, I examine the problem and resolve it, but it's over something more than grade 9. So much is about grade 11 and 12. That is seconds. Right. This is very important that we understand that. It is very, very important that we understand that. So come on, mona rebuaka horizontal movement of an object. Because the object is moving horizontally. Again, it is resting on the surface, and then you are applying a force, and then the object is being displaced. The object is being displaced. I don't want to say that because how object move, only a certain amount of velocity. It's a mayangayo. Ona object it's a manfela. It's a certain velocity, and then an initial velocity, final velocity. It at rest, the velocity was 0, then we move, then in a final velocity. And then we move the distance in what we call displacement. But we will deal with many of these things when we get there. Ke batla re kgutlele ka difosong ka moo. Ke batla re kgutlele ka moo. Ka difosong. Okay. Let's go on, sir. Right. Har shebe potso ke ena mo. But identify force 1, 2, and 3 as either a twist force or a push or a pull. Right. I'm not very good when it comes to drawing. Okay, how do you get it? Gonna little box. Kili. Ona le ngwana ka mo. So go. Alright, mare baya kwa. O phulela kwa. Mogotsi wa hae kuona ka mo. O beile matso a hae mo. O phushitsa kwa. But when I identify force 1, 2, and 3 as either a twist force, a pull, or a push. Ona wa pusha oya kwana luna wa. Again, so mo, is this a push, a pull, or a twist? Ona o pusheta kwa. Le ona o pusheta kwa. So come on, is this a pull, a push, or a twist? Kapa, is it a pull and a push at the same time?
Push.
It's a push again because oyemeka pili wa pusha. Le nna ke emeka morao ke a pusha. Again, so come on, it is a push. So come on, there are important things to say. Halamu. How about one about pusha? Baya in this direction. If we draw a compass north, east, south, and west, ba pusha in the westerly direction. Again. So pusher, they need to overcome the weight of the object. Again, and then secondly, by overcoming the static friction that is holding the object in position. Again, and then it doesn't mean how pusher this object. I said a friction. It's not friction, it's kinetic friction. Again. So come on, German. Those are the fundamental things that we should know and understand. Harmatu about air resistance and many things that revolves around that. We will ignore the effect of air resistance in this. Just the static, kinetic, because when the object is moving, it's experiencing kinetic friction. But the kinetic friction is less than the static friction, again, because already the object is in mind. They now need to apply a minimum force, again. So there's a weaker kinetic friction that is acting on that object. Because hadina mabaka next go blel hono batla re dilane le dinthonyana tse ka reng di serious o re ke go
Planet Earth and beyond.
Okay, when you go to grade here, but study the diagram. What you wanna study the diagram? Mochupuo. Mochono kuna upula le box in this direction, in the easterly direction. Bar wena babata uri ona le force o apply a force o ya kwana. Sorry, o apply a force o ya kwana, and then ona le force o hape opposing the movement of this object. Ke force o act down between the grate and the surface where the grate is resting. Now, bare inkan. Bar horo, name the force between the grate and the floor. 5.1.
Frictional.
Name the force between the grate and the floor. Ibitswang
Friction.
friction. Frictional force. Good. And then 5.2 bebare horo. The force between the grate and the floor is a field force or a contact force.
Content force.
Contact, because the grate and the floor are in contact with one another. I get? And then number 7, onewe koloiki. Right, how do we koloi? At the center, wind switching. Wind switching. Away switching. Away switching. Away switching. Right, we switch A, we switch B, we switch C, we switch D. Now, to go back more to umbrella. Why this magnitude and direction? Remember, a force is a vector. Yeah? A force is a vector, and a vector possesses both magnitude and direction. Don't forget that. Remember, a force is a vector quantity. A force is a vector quantity that possesses both magnitude, in the size, and direction. That is what we call a vector. So come on, Joma, how do we weigh a force? The length of the arrow tells you the magnitude. This is the magnitude. Size, and then the arrowhead a pointer in the direction. So come on, the length of the magnitude, the length of the arrow, the magnitude, the size, and then the arrowhead you the direction where the force is acting. So there are two things more. Renale, the magnitude, the amount of force, and the arrowhead which points in a particular direction. Now my question is, why does it say why does A C dilikan? But bona D B hadilikan. Ina khutshwane ina itelele. Why? Why is it pointing upwards and downwards dilikan? Ke eng e shebetseng hodimo? Ke E. E shebetseng modimo ke E. E shebetseng modimo. E bitswang the normal force, I guess. Rebitsa the normal force. This is the normal force, and the normal force is counterbalanced by the weight of the object. Ena e shebile mfatse ke weight ya object. Eleganal le mass multiplied by gravitational acceleration. Why are they equal? It's because the object is not going up or down. The object is either going left or right. So come on, the forces that are going up are cancelled by the forces that are going down. So come on, normal force plus weight must be equals to 0. Because it is important that we choose the direction. We can say let upwards be positive or let downwards be negative. So Mona, we can say let up be positive. So come on, normal force minus weight, that must be equals to 0. So come on, normal force elekana weight if unga isa kankan. So that is why dilekana is because the object high movie here up or down. So come on, the forces saying up and down, they will cancel one another. That is why rendialekan. It's just that the opposite, and positive and negative. So positive and negative will cancel. Again, as electrostatic more ring positive and negative attract. No, monarchy forces. Because the object is up or down. Any force A and up or A and down is zero. That is why we have normal force, because it's up is positive. Come on, obviously negative. Normal force minus weight equals 0. How can weight in a weight is around normal force weight? And it is also important the force is a vector quantity. A vector quantity is anything that has both size, magnitude, and direction. When I apply a force, you apply a certain amount to your force in the magnitude, and then in force in this direction. So how apply a force? First of all, get the amount of a force we apply in the magnitude, and then secondly, get the direction more object and. Hence, we are saying a force is a vector. So when you apply a force, you don't apply any amount of a force. You apply a force that is specific to the requirement of that object. If you want to apply an excessive one, that is your choice. But it is important to know how object is up or down. The sum of the forces saying up or down must equal 0. Right. So why is this again? D and B. You will if D and B is again. Ki e mo tlamile mo itse. D and B ha di lekana. Why di sa lekana? E kholo ke efe mo? Yo bolellang B ha ile kholo ho D. How now D ka ba bima holo because le itse inyane ho B. So ka mantswe mang B e kholo ho D. So yo bolellang ka object. Ha D e le nyane ho B, B e le kholo ho D. Ho tlo etsahalang mo? Ho tlo etsahalang ka object. Object e tlo ya kwa towards the west kapa e tlo ya in the east direction. E tlo ya ka east again because tsane tse pedi tsona already di cancelana. Say yang modimo le kae le fatshe. Why di cancelana? It's because object ha e modimo ka ba fatshe. That's why di cancelana. So come on mo ga bona the magnitude of B is bigger than the magnitude of D. Therefore an object goes east. These are the things that you need to understand, people. These things are very important. They come as your basic for grade 10. If after grade 10 always are physics, then it is important that you understand these things. When I say we value physics, otlo sokola bophelong tla go bolelle today. Otlo sokola haholo bophelong go bolelle because haeba ha o aware ho le di subject tse tshwanang le bo history ntse di cancel le ke bo di NSFAS o tlo iphumana le university o sena funding. The qualification out because I'm sorry to say this, this subject about the module say useless. And actually hadisa fundu because remover hoya body robotics. Sabata ba in physics, ba in maths, ba in software engineering. We are moving towards that. Bo accounting, but ba in geography. Jole ba ona our toloetsa history. Unless you are corrupt enough to work your way around the politicians, then you will survive in that way. You will survive. Mare, to be honest, science politicians. Because at the end of the day, they will do what the politician requires, whether you like it or not, because and Hassan needs a mulao, Ramaphosa, because he is a politician, a corrupt one. Again. So Hassan needs a mulao. Whether you are a physicist or whatever, you will bow down to that. At the end of the day, because Milao Aibeyang is satisfy yen, Alebatuamu elected Kapabatuamu empowerang, Batuamu fanda. And at the end of the day, in the low downgrade Aloena in any field of professional nanang oyo. The world is run by politicians, whether you like it or not. What the physics it's na se re di etsa fela because at least o di entse bona batho bao ke bona bao patalang. Ai Jesus, bao patal, the devil pays you. Again, in simple terms. Right, hurry up in now that re bone, or all right, B will be the force responsible in displacing that object. So come on, German. How object move in this east direction? The first thing, B must ensure that it overcome A, the opposing force in D. Because D here in the opposite direction, you will first have to overcome the amount of energy E D supplier to the system. And then once we overcome, then you will need to overcome the weight of the object. Once we overcome, you will need to overcome the static friction of that object. Once we overcome, then the object will begin to move. So come on, Jama. If force B is 20 newtons, because the force is measured in newtons, and then D is 15 newton. Auto 20 minus 15 no sala 5. Maybe 5 yena is setting or overcome a static friction, maybe got 2 or sala 3. So come on, 3 is the force that is doing work. 3 becomes the net force, a single force that has the same effect as those that acts as a combination. But just about wara for no, and to tell that the Halosa Hantel Wena or grade 10. Marapoto in give the correct letter of the arrow representing each of the following forces. The force exerted by the man on the cart. The force exerted the man on the cart. Here is a man or exert a force more. Force I exert, is it a pull or is it a push? The force that is exerted by the man on the cart. It's a push. Again, so the individual is pushing. It's a push. Again, right? Bebare 7.1.2. Bebare give the correct letter of the arrow representing what now? The weight of the cart. Giving representing the weight more of the cart. You also F C again, because weight of the object is always directed downwards. It in C. So C represents what now? The weight of that object. Right. And then 7.1.3. Bebare the force of friction between the wheels of the cart and the ground. The force of friction between the wheels of the cart and the ground. It represents what you I call a C represent a weight. Come on, Tomang, it has to be D. Because D here in the opposite direction. And anything opposing the movement of an object here in the opposite direction. The force of friction between the wheels of the cart and the ground. Force of friction, how Yona iyakai kwa. Come on, Tomanki, D. D is the one that represents what now? The frictional force, which is a force that is acting in the opposite direction. Onajole haki pula this a vapor up here in this direction. Only force of friction in the opposite direction. Right, Area 7.1.4. The normal force, the force of the ground on the cart. Can I give you normal force? A represents the normal force. Normal force so equal to the weight of the object. And then the sum of those two must be equals to 0. Why? Because object is up or down, either left or right. So it normal force is A. My father. And then 7.1.1, 7.1.2, 7.1.3, 7.1.4. I get Berea 7.2. 7.2. If force D equals 44 Newton, force D equals 44 Newton, and force B equals 120 newtons. Calculate the net horizontal force exerted on the cart. Also indicate the direction of the net force. Babata F net. Iling a single force that has the same effect as those that acts as a combination. Okay? So come on, Jamang. Hey. Banna late, man. Hey. Ni late. So sizofuna futhi senze kanje ke. Unfortunately we will not have a class namhlanje. Kodwa sizoba ne class ngomso. Ngomso ni available what time? Ani esikoleni nandithi. And ndizonenzela i-class khana lelo ngena kanoma. Usani? Ka 12 ngo-10. Ngo-10 ekuseni ntathu. Ngo-10 ntathu. Umqalele nalowa. Ngo-10 until 11. Ngo-10 ntathu. Ngomso. Enhleke fanele ndithe 8. Right, harubaka Fnet ne. Fnet. Mona, it is important that we choose the direction because anale force tse pedi tse yang in opposite directions. So the tlanka force A yang ka will be as a positive. So the FB minus FG. Again, FB rebleletswe we take 120 Newton minus 44 newtons. Give guy 120 minus 44.
76 newtons.
120 minus 44. Again, 0 and minus 4 eba 11 eba 6 11 minus 4 ki 7. 1 minus 0 ki 1. Again, you have 176. Emma. 76. 76 newtons. And because a positive, it is going in the east. Skalubala will specify the direction because we are dealing with a vector. Again, a vector in the size, give guys size 76 newton, and then direction in east. This is very, very important. Unfortunately, the offer chance and then we are done for today. We are fully